Numbers are everywhere in our daily lives, from counting objects to measuring distances. But not all numbers are the same. Today we'll explore two important types, rational and irrational numbers. Understanding the difference between them is fundamental in mathematics and helps us make sense of the world around us. Let's start by looking at what makes a number rational or irrational, and why this distinction matters. A rational number is any number that can be expressed as the quotient or fraction of two integers, where the denominator is not zero. In other words, if you can write a number as a simple fraction like a b, it's rational. Rational numbers include positive numbers, negative numbers, and zero. They can be whole numbers, fractions, or even repeating decimals. Let's see some examples to make this clearer. Let's look at some examples of rational numbers. The number 2 is rational because it's a fraction of two integers. The number is also rational since it can be written as -31. Even decimals like 0.75 are rational because 0.75 equals 34. Repeating decimals such as 0.333 are rational too since they can be written as 13. As long as a number can be written as a fraction, it's rational. An irrational number is a number that cannot be written as a simple fraction. These numbers cannot be expressed as the ratio of two integers. Their decimal expansions go on forever without repeating a pattern. Irrational numbers are just as important as rational numbers, and they appear in many areas of mathematics. Let's see what makes a number irrational. Some famous examples of irrational numbers include pi, which is approximately 3.14159, and the square root of 2, which is about 1.41421. These numbers cannot be written as fractions, and their decimal parts never end or repeat. Another example is the mathematical constant e, which is about 2.71828. These numbers are crucial in many scientific and mathematical calculations. One way to tell the difference between rational and irrational numbers is by looking at their decimal expansions. Rational numbers either terminate like 0.5 or repeat a pattern like 0.333. Irrational numbers, on the other hand, have decimals that go on forever without repeating. For example, the decimal for pi never ends and never forms a repeating pattern. Imagine a number line. Rational numbers can be found at specific points along the line, including fractions and whole numbers. For example, 2 is exactly halfway between 0 and 1. Rational numbers are everywhere on the number line, filling in the gaps between whole numbers with fractions and decimals that repeat or terminate. Irrational numbers also appear on the number line, but they never land exactly on a fraction or a repeating decimal. For example, the square root of 2 is somewhere between 1.4 and 1.5, but it can't be written as a simple fraction. These numbers fill in the spaces that rational numbers can't reach, making the number line complete. A key feature of rational numbers is that they can always be written as a fraction, like 7/8 or -2/5. This is not possible for irrational numbers. No matter how hard you try, you can't write pi or the square root of 2 as a fraction of two integers. This is what sets rational and irrational numbers apart. Repeating decimals are a hallmark of rational numbers. For instance, 0.666 is a repeating decimal and can be written as 23. If a decimal repeats a pattern, no matter how long, it's rational. This is a useful trick for identifying rational numbers when you see a decimal expansion. If a decimal never repeats and never ends, it's irrational. For example, the decimal expansion of pi is 3.141592653, and it goes on forever without repeating. This is a clear sign that pi is irrational. The same is true for the square root of 2 and other famous irrational numbers. Rational numbers are represented by the symbol q, while irrational numbers don't have a special symbol but are often described as real numbers that are not rational. Both types together make up the set of real numbers, which includes every possible point on the number line. Rational numbers are everywhere in daily life. When you split a pizza into 8 slices and eat 3, you've eaten 3/8 of the pizza, a rational number. Money, measurements, and most calculations we do every day involve rational numbers. They're practical and easy to work with. Irrational numbers also appear in nature and science. The number pi is used to calculate the circumference of circles, and the square root of 2 appears in geometry, such as the diagonal of a square. These numbers help us understand the world in ways that rational numbers alone cannot. If you're unsure whether a number is rational or irrational, try to write it as a fraction. If you can, it's rational. If you can't, and the decimal goes on forever without repeating, it's irrational. This simple test works for most numbers you'll encounter. A common misconception is that all decimals are irrational. In reality, many decimals are rational as long as they terminate or repeat. Only those decimals that never end and never repeat are truly irrational. Understanding this helps avoid confusion when classifying numbers. The discovery of irrational numbers dates back to ancient Greece. Mathematicians were surprised to find numbers that couldn't be written as fractions, like the square root of 2. This discovery changed the way people thought about numbers and mathematics forever. Let's summarize the differences between rational and irrational numbers in a simple table. Rational numbers can be written as fractions, have terminating or repeating decimals, and include numbers like 1, 2, and 0.75. Irrational numbers cannot be written as fractions, have non-terminating, non-repeating decimals, and include numbers like pi and the square root of 2. Understanding the difference between rational and irrational numbers is important in mathematics and science. It helps us classify numbers, solve equations, and understand the structure of the real number system. This knowledge is foundational for more advanced math topics. To recap, rational numbers can be written as fractions and have decimals that terminate or repeat. Irrational numbers cannot be written as fractions and have decimals that go on forever without repeating. Both types are essential parts of the real number system. Now you know the key differences between rational and irrational numbers, along with some common examples. This understanding will help you in your math studies and in recognizing different types of numbers in everyday life. Keep exploring and you'll discover even more fascinating facts about numbers.